Okay, welcome to week 6, day 3. And we're going to be continuing our work with rational operations, but on day 1 we simplified, multiplied, and divided, and today on day 3 we're going to be adding and subtracting. And addition and subtraction of fractions is more complicated than multiplication and division, so I'm going to be doing several different numerical examples to refresh your memories on some of the things you need to keep in mind. So we're going to actually start off with a strictly numerical example. So what we've got here is we've got 2 fractions that we are being asked to add, and so in order to add these fractions we are going to need a common denominator. Now, you can do common denominators a lot of different ways, but what we recommend you do is you get the least common denominator, the smallest common denominator you possibly can, because then what's going to end up happening is then you end up generating fractions that are bigger than they need to be, and then you end up having to do more reducing and things like that. So in order to find the LCD for these 2 fractions, what we would need to know is we would need to know how they factor. So this 35 right here factors as 7 times 5. And this 20 right here factors as 5 times 4. So what you see is that both denominators already have a 5 in them as a factor. In order to give them the least common denominator, what we would need to do is we would need to give this first fraction a 4. And so we're going to multiply the denominator by 4 and the numerator by 4 to give them that common denominator. Okay, remember that you have to multiply by 4 on top and on bottom so that you are not actually changing the value of the fraction. And then the same thing goes for the second fraction. We are going to multiply it by something on top and on bottom. And what this denominator is missing is the 7. So we are going to multiply this by 7 on top and on bottom. So once again, the value of the fraction is staying the same because 7 on top and on bottom means we're just multiplying by 1. But what that does is it now gives us the first fraction right here will now become 24 over 140. And then what the second fraction will become when we multiply this together is it will become 21 over 140. So we have given the 2 fractions a common denominator. It is the smallest common denominator possible. It is 140. And we generated that LCD by figuring out which factors did we need to multiply into a given fraction so that each denominator would have exactly the same factors in it. Once we've given that least common denominator to our 2 fractions, now we can actually add the 2 fractions. And so we add the 2 numerators together and we get 45 over 140. Technically, this is our final answer. It doesn't actually happen often that what we are going to be generating is things that reduce. Now, this particular numerical example does reduce. There is a 5 that would reduce out of each of those 2 things. And so you could reduce it down to 9 over 28. But the stuff that we're going to be dealing with that are rational expressions that have variables in them, they very, very rarely will simplify and reduce once we have added and subtracted them. So don't think that it's required or a common thing. Okay, so our first example is right here. Here's example 1. And as with the day 1 notes, if at any point you need to just pause it and copy down the problem or the sentences or anything, that's fine. Remember that you are not expected to print these notes out at all. Okay, I'm just trying to shorten the video and save some time. So in order to figure out what our LCD is going to need to be, we need to figure out what factors the denominators have. So we factor this quadratic right there. That quadratic factors as x minus 1 and x minus 5. So what we see is both denominators have an x minus 1 in them. The first denominator also has an x minus 5, and the second denominator is missing that. So this is the equivalent if I asked you to add, let's say, 2/15 and 1/5. Okay, the 15 right here has a 5 and a 3 in it. So all I would have to do to give these two fractions a common denominator is multiply this second fraction by 3/3. So the first fraction has all of the factors that it needs to have in the denominator already. The second fraction is just missing one of the factors. So that is what I multiply by. So that is the situation that we have found ourselves in. So we now know which factor our second fraction is missing. And so what we are going to do is multiply this second fraction by x minus 5 over x minus 5. Okay, what that means is the first fraction does not need any changes to it. It is going to stay 4x on top. We're going to go ahead and write the denominator in its factored form. You don't have to. You can revert back to writing it as this quadratic. Okay, but we don't require that most of the time. Just keep it in mind because once again, if you are taking something that's multiple choice like your quizzes, you might be given answers that have that denominator foiled back out. And then the second fraction, I need to take the 6 and distribute it to the x minus 5 on top, and so it becomes 6x minus 30. And then on the bottom, these two factors are going to now be multiplying together. Once again, I'm choosing to leave them in factored form. Okay, so don't feel like you have to FOIL them out, but you can if you want to. And now the two denominators are identical, which means now the two fractions can add. So now I can go ahead and add the numerators together. When I add the numerators together, I will have 10x minus 30 on top, and I have my x minus 1 and x minus 5 in the denominator. And that is an acceptable version of the final answer. There are other forms you could write it in, you guys. I don't want you thinking that you have to stop here or that you can't go any further. You could pull a 10 out of the numerator and leave it as 10 times x minus 3. Doesn't really accomplish anything, so you could leave it written like this. And once again, I know I'm being repetitive and I apologize for that, but you could choose to FOIL those denominators back out. And so you could take either one of these numerators and you could write it over x squared minus 6x plus 5. All of those are acceptable versions of that answer. Okay, I'm just telling you the most common way that we leave our answers written. Okay, so the second example, okay, is a situation where if I asked you guys to add 2/3, let's even go ahead and do a subtraction, and 4/7. Okay, what I have given you is a situation where the two fractions do not have a common denominator, but they also do not already have any factors in common. So this is the situation where our LCD would be 3 times 7. It's going to be 21. And so if this is the case, if you have no common factors between your two denominators, then you take each fraction and multiply it by the other denominator. So I'm going to multiply the first fraction by 7/7. I'm going to multiply the second fraction by 3/3. And what that would make this numerical example become would be 14/21 minus 12/21. And now they have a common denominator. And so that is the situation we have found ourselves in with example 2. Okay, so because x plus 3 and x minus 4 cannot be factored any further, and they have no factors in common with each other, we are going to need to multiply the first fraction by x minus 4 over x minus 4, and multiply the second fraction by x plus 3 over x plus 3 to give these two fractions a common denominator. Now, one thing that you will need to notice, and it does take practice to learn, is that even though I don't have to multiply the denominators out, I can leave this denominator written as x minus 4, x plus 3. In order to eventually combine these two fractions, you do actually have to multiply the numerators out. So we are going to have to FOIL in this case. We are multiplying x minus 4 times x plus 2 in our numerators. And so we will need to FOIL. And when we FOIL these two out, what we would get is x squared minus 2x minus 8. And then there's our minus sign, because we haven't begun to combine these fractions yet. And then when I multiply these together, sorry, I don't know what just happened there. Multiply those together. I don't have to FOIL, I just need to distribute. And so what that would be is 3x plus 9. And then these two are multiplying together in the denominator. And once again, I can choose to FOIL them out or not. So I can leave them like that. Okay. Now that the two fractions have their common denominator, I can go ahead and subtract them. And this is actually one of the more common places where people do make mistakes. Everything in this numerator right here is being subtracted. And so we need to remember that that minus is going to distribute to everything in that numerator. So when we combine our two fractions, we have our x squared here, and there is no quadratic term to combine with it, so it just stays x squared. Then right here we have the minus 2x, and then we are subtracting this 3x right there. So we do end up with minus 5x. And then we have this minus 8 right here, and then we are subtracting the 9. That's right there, so we do end up with minus 17 over our LCD of x minus 4 times x plus 3. Okay, and this is our final answer. If you wanted to, once again, you could FOIL out the denominator, but it really doesn't accomplish anything. Okay, so it's just an option for you. And the final example here is one just like actually the numerical example at the beginning of today's notes. When we look at the factors of this first denominator, what we get is x plus 5 and x minus 5. Of course, it was a difference of 2 squares, so it does factor. When we look at the factors of the second denominator, what we see is that it factors as x minus 2, x plus 5. And so in this instance, what we see is that both denominators do have one factor already in common. They both already have the x plus 5. But this denominator is missing an x minus 2, and this denominator is missing the x minus 5. So what we will have to do, and for the sake of space, I'm going to actually just rewrite this out really quick. This is where we are right now. And then what I'm going to do is I'm going to multiply the first fraction by x minus 2 over x minus 2. And I'm going to multiply the second fraction by x minus 5 over x minus 5. And so now the two denominators will have all three factors in common with each other. And so once again, when I multiply all of this out right here, I can leave the denominator written in its factored form. So it's now going to have factors of x minus 2, x plus 5, x minus 5. But I have to FOIL the two numerators together. And when I FOIL these two together, I just get x squared minus 4. And then the minus sign again, because I still have yet to start combining the fractions. And then when I multiply these two together, the denominator is going to stay in factored form as well. And the factors don't even have to go in the same order. They can go in any order that you want them to, as long as they have the same three factors in there. And then I will need to distribute to multiply the two numerators together, and I will, of course, get 3x minus 15. And now I need to go ahead and combine the two fractions. So I've got my LCD, x minus 2, x plus 5, and x minus 5. And I've got this x squared right here. There's no quadratic term in this numerator to subtract from it, so it stays with an x squared right there. There's no x term in this numerator, so I'm just going to be subtracting the 3x that's in this numerator, so just minus 3x. And then I have the minus 4 right there, but then I'm subtracting this minus 15, which is going to make it become a plus 15. So I have this minus 4 right here, and then this is now plus 15, and so I get plus 11. And so that is my final answer. Okay, so you can see that it does require more work and a deeper understanding of fractions and factors of denominators and LCDs and things like that to add and subtract this. So that's why we gave it its own day. And we will also be breaking up our solving next week, utilizing this method as one day and another method as a separate day to try to keep them straight and give you additional practice with this. Here are your practice problems for this week. So if you did not print out these notes, just pause at this point, copy down the problems. Let us know if you need additional tutoring other than the Zoom times we have offered. Good luck and have a good rest of the week.